Welcome to today's ConSteel webinar. Today's topic is crane load according to the EuroCode 1. My name is András Herbai. I'm going to head today's presentation. Just for some practical information, control panel can be hid with the red arrow button, and question or message can be sent with the chat option. At the end of the webinar, I will answer them. Few words about the summer ConSteel webinars. Today's webinar is the first one in this series. Next webinar will be on the next Thursday about the meteorological load generation, and the last one will be on 24th of June about the special modeling and calculation of the corner zone in case of tapered and hinged frame. Today's webinar content will be the following. At first, I will show you the crane load creation possibilities in ConSteel. Then I will show you the influence graph analysis. Then I will demonstrate the positioning of crane load manually or loading on an influence graph. A short introduction to the crane load. Why crane load is special? Because it's a moving load. Parts of the crane can move in different directions simultaneously, and it generate vertical and horizontal effects. A crane load has a special load standards in EuroCode. This is the EN 19913 standard in the EuroCode series. What kind of crane forces are determined? At first, the vertical forces, self-weight of the crane, the first one, except the lifting attachment and the ropes or the chains of the lifting. The second one is the hoist load, plus the lifting attachment and the ropes or the chain. On the figure, you can see the difference between the two vertical loads. On the other figures, you can see the arrangement of the vertical load. On the first figure, you can see the minimum vertical load on the left side when the crane is unloaded and the crab is standing on the other pass, and the wheel load is minimum on the left side. On the next figure, you can see the maximum vertical load on the left crane way. In this situation, the crane is loaded and the crab is standing on the focused pass. Let's see the horizontal crane forces. We have the first one is the acceleration of the crane bridge. It is a longitudinal force. The acceleration of or braking of a crab or hoist block. This is a transverse load. Skewing of the crane bridge. In case of open air crane, we have wind load also. We have a test load for self-visibility limit states, and the last two load types, force types, is the accidental actions and the buffer forces when the crane overruns and goes to the buffer, and the tightening force when the load or the lifting attachment collides with an obstacle. From the crane forces, groups of loads have to be made according to the attached table. This table can be found in the EuroCode. we have 7 ultimate limit states groups of loads, 1 serviceability limit states groups of loads, and 2 accidental groups of loads. The crane forces shall be taken into account with the dynamic factors. In each of the factors depend on the group of loads. Here you can see which dynamic factors have to be used. And one group of loads shall be handled as one crane action. In every design situation, the most dominant group of loads will be the crane action. Combination rules for crane action with other actions. In every design situation, the most dominant crane group of loads shall be taken into account. The selected group of loads is the crane action in the actual design situation, and the determined crane action shall be combined with other action by the rules of the EuroCode 0. And here you can see the safety and the combination factors for the crane loads. The safety factors in unfavorable situation is 1.35, in favorable situation is 1. Combination factor is 1 and 1.5, or the ratio between the permanent crane action and the total crane action. Okay, let's go to the ConSteel software. I would like to show the crane load capabilities of ConSteel with this 3D hole. The geometrical parameters of the hole are the following. And then the span of the frame is 20 meter, the length of the hole is 40 meter, and the distance between the frames are 5 meter. To place a moving load on a 3D model or analyze an influence graph, it is necessary to place an influence line on the model. All of the moving load related functions can be found on the load stubs. And here you can see the crane load function groups. This group is contained 4 different functions. The first one is the influence line. Influence line can be placed by selection with this function, or by drawing. In this case, the first one and the start point and the end point of the line has to be picked by the mouse. Now I'm use the selection option. In this case, all of the members has to be selected, and all of the selected members have to be laid in one line. Okay, so now I select the crane way to create an influence line on this. But before I start it, I check in the double influence line. If it's necessary, you can create a double influence line. For example, now it is necessary because I would like to demonstrate a bridge crane. So that's why I create a double influence line. So now I have to select the first influence line, and with the right mouse button I close the command, and I select the next one, and also closed with the right mouse button the command, and these yellow lines show the created influence line. Okay, so the influence line is created. The next step is to create the crane load with the third crane load icon. Crane loads can be defined in three ways in ConSteel. The first one is the standard. In this case, ConSteel uses the EuroCode recommended formulas. Just the proper parameters have to be set, and the groups of loads are created automatically according to the EuroCode. The next type of crane load is the standard load-based crane type. In this case, the EuroCode defined crane forces have to be set in the table for each wheels, and the groups of loads are created automatically according to the EuroCode, and the wheel loads are automatically calculated in this case. And the last one is the user-defined crane load. In this case, the wheel loads have to be added manually for each wheel. Now I demonstrate the standard crane load definition. At first, the geometrical properties of the crane have to be set. First of all, the span of the crane have to be set. Now it is 20 meters. The minimal distance of the trolley is 1.5, so I leave on default. The next parameter is the number of the axis. Now it is 2, so I leave these settings on default. And the last geometrical properties is the this distance between the axis. Now it is 1.5 meter. Okay. In the next field, in the loading properties field, we can set the self-weight of the crane. Now it is 100 kilonewton. The self-weight of the trolley, it is 20 kilonewton, and the elevated weight is 1000. Sorry, it's too high. It's 300 kilonewton. By clicking on the dynamic factor button, the dynamic factor values can be seen. These factors are used to create the groups of loads of the crane. The default values are the EuroCode defined minimum values. If it is necessary, the factors can be modified manually. Now I leave this on default. And in the last field, the driving properties can be set. These parameters depend on the used crane. Usually these parameters are provided by the manufacturer of the crane. But here you can set the number of the single wheel drives, the type of the wheel drive. It could be central or individual. Here we can set the system of the crane. The meaning of this crane system can be seen in the appendix of the EuroCode, the crane load EuroCode standard. Here you can set the friction factors between the wheel and the rail, and here we can set the guiding device type. We have two types of device: the flanged wheel, this is a normally used guiding device, and we have a guided pin. And here we can set the parameters of the guiding device, but now I leave on default. On the bottom of the dialog, the calculated wheel loads can be seen in each group of floats. The group of floats can be changed with the drop-down menu. So here you can see the 7 different group of floats, and we can see the calculated loads for each wheels. The first number in the name of the wheels show us the number of the axis, and the second one is show us the number of the wheel. So these two column is the first axis wheels. The second one is the second axis wheels. Okay, with the apply button, we can create the crane load. Created crane load can be placed on the model in two ways. The first way is to place crane load manually. The second is to place crane load by loading an influence graph. But before I start, I create some crane load cases. So now I close the dialog and go to the load case and load group dialog. In the load group field, we can find a dedicated crane load group. The safety factors and the combination factors is according to the EuroCode, and with the new load case button, we can create several number of load cases in the crane load group. Okay, let's go back to the crane load dialog. So now at first I demonstrate the manual crane load placing. On the bottom of the dialog, you can find a place load button here. With this function, the selected group of floats, I go back to the crane load dialog. So here you can see the selected group of floats. So this selected group of floats can be placed manually with the place load button. Okay. First of all, the influence line has to be selected. Just click on with the left mouse button one of the influence line, and with a simple click, the selected group of floats, the crane loads, can be placed in the selected load cases. So now I select one of the crane load case and I place again somewhere on the model. So now you can see the crane load is placed on the model manually. On the dialog, you can set the direction of the placement and the position of the maximum wheel load. So the maximum of the wheel load could be on the left pass or on the right pass, and the snap point of the positioning also can be set. So it could be the first axis or the last axis. Okay, so this is the manual placement of the crane load. The second way of crane load placing is to load an influence graph. For this, influence graph analysis has to be run. For an influence graph analysis, we have to set influence graph parameters. So in the crane load group, we can find an influence graph icon. With this function, we can create several influence graph parameters. First of all, the influence line has to be selected from the drop-down menu. Now we have just one double influence line So that's why we have to select just this one. The second parameter is the place of the investigation. In the current version of ConSteel, cross-section can be selected with the black arrow button. Now I select the middle point of the craneway. The next properties is the type of the influence graph. In the current version of ConSteel, we can run displacement influence graph, internal forces influence graph, or reaction forces influence graph. In case of reaction forces, and point support has to be selected. Now I select the internal forces and the major axis bending moment. The last property is the direction of the unit load. Now I select the -z according to the global coordinate system, the -z unit load. With the apply button, we can create an influence graph parameters. With the new button, we can create another parameter, influence graph parameters. Now I select this point. The type of the influence graph is still internal forces, major axis bending, and the direction of unit load is -z. It's okay. And create a new one on the bottom of the column. Sorry. Okay. The type of the influence graph is internal force, major axis bending, but the direction of the unit load is +x. With the apply button, the influence graphs parameters are created. To run an influence graph analysis, we have to go to the Analysis tab. And on the Set Analysis Parameters dialog, we have to select in the Static Analysis field and the Elastic Analysis of influence graphs options. And with the calculation, we can run the influence graph analysis. Okay. The analysis is done. From the second drop-down menu, we can switch between the different influence graph. This gray rectangle shows us the place of the investigation. Okay. By clicking on the graphical area with the right mouse button, you can select the Load Influence Line options from the appeared menu. With this option, the selected influence graph can be loaded with a previously created moving load. In the moving load field, one of the previously created moving load can be selected. Now we have just one crane load. In case of crane load, the group of loads can be selected manually, what we would like to place or to use to loading the influence graph, or the dominant can be selected automatically by ConSteel. Now I use the automatic selection. And also the position of maximum wheel load can be selected manually. It could be on the left pass or on the right pass, or the dominant position can be selected by ConSteel automatically also. Now I select the automatic selection of position. In the loading field, we can load the selected influence graph on the positive zone or on the negative zone. Now you can see the load graphic is showing us the position of the load, and in the value field show us the actual value of the loaded influence graph. Now it is a kilonewton meter. It's a bending moment, major axis bending moment, because the created influence graph is a major axis bending moment influence graph. Here you can see. So we can loading the influence graph for maximum positive value and for maximum negative value, and the load group is automatically selected, and the position of the maximum wheel load is automatically selected. And the placed loading can be saved in one of the previously created load case. Here you can see from the drop-down menu you can select one of the created load case. If it is necessary, with the 3-dot button you can create a new one. With the save button we can save the placed load or the used load in this position to the selected load case. Let's see the second influence graph. You can see this is the position in case of maximum negative value. Here you can see the maximum negative value, and this is the position of the crane load for maximum positive value, and here you can see, and this position also can be saved to the selected load case. And let's see the last one. We can load with the crane load this influence graph also. We can save to the selected load cases. Okay. The saved loads can be seen on the loads tab. So here you can see the dominant crane load, crane group of loads. The crane loads is placed by loading the influence graph on the dominant position, and saved to the one of the previously created load cases. And now the load combination can be generated. So if we use the automatic generation of load combination functions of ConSteel, we can generate the necessary load combinations according to the EuroCode. Okay, for now I'm done with my presentation. I would like to thank you for your attention. I hope you enjoyed and learned in this presentation, and I would be happy to welcome you back to our next webinars. So thank you very much and goodbye.